Today I will discuss shortcut for hybridization. I will tell you shortcut. This shortcut you have to find out any molecule hybridization less than 30 seconds. Less than 30 seconds. Don't use more than 30 seconds because in entrance exam we have to write the answer that in time. So you have to use that, utilize that time management so that you can write down whatever that molecule hybridization less than 30 seconds. I will give the one trick for you. So here hybridization equal to V plus M minus C plus A by 2. So what is that? V equal to valency or group number. Valency or group number. M equal to monovalent compounds. Monovalent elements. Generally, we consider as elements. So what are those? That is first the A group elements and seventh A elements, because these two only enter periodic table. This is +1 oxidation. This is -1. We wrote monovalent means it should be 1, either plus or minus. C means that is a cations. Cations means positive charged particles. A means anion. This is a negative charged particles. Means that whatever the molecule having positive charge, whatever the molecule having the negative charge, you have to consider that one also. So for example, I will give the one example. You have to find out that hybridization of this molecule. So here I will discuss CH4. This is we don't know that hybridization of this compound. So how to find out? First, the hybridization equal to what is here central element? Carbon. Carbon group number 4 plus number of monovalents. So how many monovalents are there? Only monovalent is here hydrogen. How many hydrogens are there? 4 plus minus any charge is there? Any cation? Any positive charge is there? No. Any anion is there? No. By 2. That is 4. If it is here 4, that is 1s and the remaining 3 are p. sp3. 1s orbital and the remaining 3 are p. 1s 3. So that is can I call s orbital 1 plus p orbital 2. That is 4. That's what it is, sp3. So I will write here. If it is whatever that we calculation, if we get 7, that is sp3d3. If you are getting 6, that is sp3d2. Then if you are getting 5, sp3d. If you are getting 4, then sp3. If you are getting 3, sp2. If you are getting 2, sp. Okay. So for example, water molecule is there. This is a water molecule. Here, which one is the central element? That is oxygen is central element. Here, hybridization equal 6th group hydrogen. Again, number of monovalents. So here, monovalents is hydrogen -0 +0 by 2 by 2. So this is total 8 by 2. That is a 4 sp3. Okay. So here again, we have to find out a number of lone pairs. How many lone pairs? How to calculate? Whatever that here we are getting the answer minus number of total surrounding atoms. Here oxygen surrounded by how many molecules? 2. Whatever that molecules, no need to check it out whether it is a monovalent or whatever that molecule around the oxygen, you have to consider how many are there? 2. That is 2. That is 2 lone pairs are there. That's what we wrote. A hydrogen water structure is like this. So here 1 lone pair here, 1 lone pair here. This is sp3, 2 lone pairs. 2 lone pairs. So for example, if you are getting that, if you are you have to find out that NH3. Here generally 1 lone pair is there. Okay, so here we are getting hybridization equal to what is the group number of nitrogen? That is the 5th group plus number of monovalents. 2 or 3 are there. -0 +0 by 2. That is 4 sp3. So number of lone pairs 4 minus number of surrounding elements 3 are there. That is 1. This is a lone pairs. Okay. For example, NH4 plus is there. NH4 plus is there. So in this case, hybridization equal, so group number of nitrogen is a 5 plus how many monovalents are there? 4 minus cation. How many are there? Plus 1 plus anion 0 by 2, that is 8 by 2, that is 4 sp3. Again, number of lone pairs equal to 4. This one 4 minus number of surrounding elements, how many? 4. So 0 lone pairs are there. For example, they will give the compound is a xenon molecule, xenon O3, then xenon OF4, then xenon O2F2, then xenon F6, then xenon OF4 already is there now. So here, so in this molecule, one more shortcut I will discuss. So one more shortcut. If it is a xenon is there, you should write down sp3. Once check it out by using this formula. So here any monovalent is there? No. So that is only sp3. Here sp3. How many monovalents are there? 4. You should write down by 2. So how many? 2. That is sp3 d2. Monovalents by 2. So how many monovalents? 4 monovalents. 4 by 2. That is 2. That is sp3 d2. So for example, this case. Next case. So here xenon is there. That is sp3. How many monovalents are there? 2. 2 by 2 means 1. Here sp3 d3 because the 6 are there by 3. Only we have to check it out monovalent. Don't go to the any other. If it is any other, you have to check it out this one. This is the best method to find out the hybridization. Less than 30 seconds. Less than 30 seconds. Okay. So now I will give another question. This is very, very important question. IF7, then I3 minus. IF7 and I3 minus. So in this case, IF7 means here, which is central metal, that is central element, that is iodine, less electronegative element. So hybridization equal to 7 plus here surrounding elements are 7 by 2 because minus 0 plus 0 by 2. So it is a 7 means sp3 d3. Number of lone pairs equal to 7 minus here also 7 now, it is 0. But whereas in this case, we no need to write like this because it is only single now. So you have to write down this one I into I2 minus. I into I2 minus. So both are same. So here we consider again central element, that is iodine, 7th group elements plus monovalents of 2. So minus cation. Cation at 0 plus cation is 1 by 2. That is 10 by 2. That is 5. So here sp3d. sp3d. So number of lone pairs. So lone pairs equal whatever that you get here 5 minus number of surrounding elements. How many are there? 2. So here lone pairs are 3. This is the technique. So you can easily identify that hybridization whatever the molecule.